listen to this later.
Elaine, she was here.
Yeah, but I got still somebody else out. All right, so yeah, if you only negative work could make something go fast or slow.
So did I basically just finalize?
Not even do any calculations at all. Yeah, right. I just realized that it started fast and went slow. What kind of work would do that? Only negative work would do that. Which you should have got because we talked about catching a baseball would be negative work. You've got a shopping bag and you're walking along on a horizontal floor. Your force is up. You're moving this way. That's 90 degrees. There is no work done by your hand because when the force is 90 degrees from the displacement direction, zero work. But if you're going up an escalator, well now you're going both cross and up. So a component of your hand's force is actually doing work. So going up an escalator, your hand is doing a bit of work. It's actually the vertical component of your force is doing work. So now no longer when you're going up an escalator is the angle between the force and displacement. Now it's not zero. So you've got a displacement going this way and a force going this way. It's no longer zero. So you're doing work. Okay, let me give you the short answer for the escalator. Now the angle between the direction of displacement and force is not 90, so you're doing work. You're doing some work. The angle between force and displacement no longer 90, you're doing work. That's the short answer. Okay? So don't bother copying all these words. Here's a problem. We had an angle of, well, I guess the force was opposite the direction of displacement. So that's 180. So that's why you get negative work. It's F times D. The angle between the force and displacement is 180. So the cosine 180 makes it negative and just simple it up. Okay. All right, all good on white girls. Can I move on for one? Okay.
I think we're still kind of on the, I don't know if I just calculated something wrong, but I did like negative 3 times 10 to the third times 850.
Yeah, that's good.
And I got negative 4.2 times 10 to the 3 wrong questions. Thank you. Sorry.
Well, yeah, do the.
I read the wrong question.
Yeah, that's good. All good, girl. Yeah.
So I got the 2.5 and negative 2.5 times 10 to the 6, but I did something different. I did.
Well, I really, when it must round, usually these textbooks are right, it must have rounded up to 2.6.
Okay. Too bad, but I did my work is different. I did like just force times displacement.
Yeah, force times displacement, and you did get an answer of negative. See, what happens here is you could have said, if you did this, oh, F times D, oh, and the work is negative because we've got a 180 degrees, fine. You don't have to put this in. You could just say, I already know cosine 180 is negative. Great. All right, so the cable lifts up a 1,200 kilogram elevator. The key word is constant velocity. What's the work done by the elevated tension? Once I know that it's constant velocity, the tension equals the weight force, because this constant velocity means A equals 0. So the angle, the cosine is now 0 because the tension's up and the displacement's up. Now, you don't have to do this. Most people just say the tension's up, the displacement's up, same direction, 0 degrees. You don't have to put that cosine in there. That's up to you. So they use 9.8. I know you use 10, right? And then you multiply by F times D. And it's positive because the force and the displacement in the same direction. You can leave out that cosine 0 if you'd like. It's just, I already do it in your head. Cosine 0 is positive 1. Rounding it to 2 significant digits, joules or Newton meters, okay? What's the work done by the elevator weight? Now the weight is acting down, the elevator is going up. They're exactly equal but opposite. Now it's 180. And now, did you need to put cosine 180 or could you just put -1? Because you know that's what cosine 180 is. Sure, the weight is down. It's doing negative work, and so, you know, F times G, they use 9.8, you use 10, right, of course. Times the distance, and it's doing negative work, because it's acting in the opposite direction, okay?
For the one like above this, why didn't you multiply by 9.8.
Why didn't you what?
Oh. oh,
Yeah, I've got to
nine-
turn this math into a weight. How much, if F net is 0, then the up force equals the down force. The tension must equal the weight. And that's a good thing, because that's when you do the minimum amount of work. And an elevator would want to do the minimum amount of work, wouldn't it? All right, so that's good. And notice they're equal but opposite, of course, because forces are equal but opposite. You use 10, they use 9.8. The book will always do that. Now you've got a situation where the force, I think they asked you to compare when the force is at 25 degrees versus when it's in the same direction, 0. And you just do the math. 25 degrees where only the horizontal component does the work. That's why you have to do cosine 25. It's not applied in the same direction, but at an angle. The force and the displacement now at an angle. Now the cosine really matters. You can't just leave it out. And there you go. I think they want to ask you to compare the two. Obviously, you're going to get the most work done with the cosine of 0 degrees. Okay, good. So I think they gave you the 94 newtons. We didn't have to find it. Is that right? They gave it to you? All right. So it's pretty straightforward. Pretty straightforward. Okay, can I scroll away yet? You know I'm going to post this as a video, by the way. I am. Let me just. I'm a little ace. Okay, it's good. We're good. Just checking it. Worried that I forgot. Here we go. Remind me always to record this thing, even long after I need to just. This one's a tough one. You've got a crate being pushed with a horizontal force P and then 30. The coefficient of friction is 0.200. What should the force P be so the net work equals 0? Now, make sure you write net work is 0 when F net is 0. Net work is 0 when F net is 0. So make sure you write that down. So now it's like a first quarter problem. When does the net work equal 0? When the sum of the y's equals 0. The two down forces equal the one up force. The one up force is the normal. The two downs, yeah, the two downs are p sine theta, and g goes down as well. So that gives us the normal force. The two downs is the first quarter problem. And the x, sum of the x, f of x equals 0. That is the left force equals the right. The left force is p cosine 30. The right is friction, which is mu times normal. And then I just replaced the normal with what I got from before, the normal that I got from above. And, put the numbers in. Just put the numbers that I was given in, put the coefficient in there of whatever that was. So it's really a first quarter problem. It's equilibrium work. The net work is 0 when the F net is 0, and equilibrium problem.